Okay, this is lecture 4 in the series. Well, it's going to be a complete course on Venn diagrams, propositional logic, and predicate logic. So this will be lecture 4. On the at the end of lecture 3, this is what I had on the diagram. And at the end of lecture 3, this is what I was talking about. This is the diagram for P. P is an atomic sentence, an atomic WFF, well-formed formula. Sometimes I'll use WFF, sometimes I'll use sentence, sometimes I'll use statement, just so you'll get used to the terminology instead of just using the same thing over and over. Because if I never use WFF and you're reading some other book and you come across WFFs, you're like, wow, what's that? A WFF is just a well-formed formula. It's just an abbreviation. Anything in propositional logic which is not a WFF is not a sentence. So you have to you obey the rules, and I went over them last time, but a little later I'll go over it, more, make them more explicit. This is the diagram for P, and now let me explain why. The key is this. If I just draw the circle P like this, and I don't put anything below it, then I'm not diagramming P. I'm diagramming P because I put P below it. So this tells you what the statement is that you're diagramming, what the formula is that you're diagramming, what the sentence is. If you don't put anything below it, you're not diagramming anything. It just shows you all the possibilities. Inside P means P is true. Outside P means P is false. But you're not making any statement. Now, here, I am making a statement. I am saying P. That's what I'm trying to diagram. I'm trying to diagram P. Now, I might want to diagram not P. Okay, so I'll do another diagram. So now I want to diagram not P. So how do you do that? Well, they're going to be obviously different diagrams. So if this circle is P, inside P means P is true, outside P means P is false. The diagram for not P is this. Now, the diagram for P is this. Now, I can show you using truth tables what's going on. P, take P, P can be true. One, there's going to be two possibilities. In this diagram, inside the circle is going to stand for line 1 of the truth table. Outside will be line 2 of the truth table. When you do the diagrams, you don't put the numbers there. I'm just doing it so you can, make the connection. But inside is statement line 1. Outside is line 2. Okay, line 1 of this is a truth table. Line 1 is going to be this. Line 1 is P is true. Line 2 means P is false. Now, if I want to know what P is and what not P is, okay, look at it. Let's say I want to know what is P for line 1. Well, P is true when P is true. Line 1, P is true, so P is true, right? Okay, that's obvious. P is false when P is false. P is false when P is false. So they're just the same. Now, what about not P? When you negate a sentence, you switch the truth value. So if P is true, not P is false. And if P is false, not P is true. Now, if you want, you can put a T here, because look at, when P is true, here, the P is true. So you could do that if you want. There's no need to do that. Actually, I do it because it makes, when I'm doing truth tables, if I put the T's under each P, it makes it, I don't have to keep looking over to the left. Now, so when you see this, for example, here, not P, you're not, this should be a false. TF, FT, okay, look at, what all you care about is this and this. So you don't really care about these two. These are just a means to get there. Because P is true, not P is false. P is false, not P is true. If you want to take them out, you can. I'll take them out right now, just to might confuse things. But when you're doing truth tables, I think they're good to put in. But again, they're just a means to an end. What you really care about is what's under the negation sign. So not P is false when P is true, not P is true when P is false. Now, that should make sense. Now, this diagram here, let me do this diagram here. This diagram here says exactly what line 1 says. Line 1 says P is true when P is true. That's what this diagram here says. It says P, you look at what sentence is being diagrammed, so you have to look here or here. This is P, so we're diagramming this. P is true. How do I know that? Well, because I'm pointing to a section that is undarkened. When a section is undarkened, it means that that section is true. So this section inside P means P is true. So P is true. It hasn't been darkened. So this is how you read it. If you don't do it this way, you're going to get totally messed up. And I know from experience, because when I worked on these diagrams for a year, I was still getting messed up, but now I know how to do it now. P is true. The first thing you do is you go P, you put your finger here, and you go, it's true. Yeah, I know that because it's undarkened. Then you say when, and then you have to say what this section means. Inside P, when P is true. Okay, then you could do this. P is false. I say P is false because it's dark. P is false when. Now, what does this section mean? It means P is false. P is false when P is false. You need to go just practice that until you get used to it. I'll do it for this one here. Here's how you read this diagram. First thing you do is put your finger on what you're diagramming. Say not P. Okay? Then you go bang right there. And not P is false. Why do I say that? Because it's darkened. Look at it. Anytime it's a darkened section, you say false. Not P is false. Then you say when. When what? When P is true, because you're inside P. And then you say not P is true. Not P is true. Why do I say that? Because it's undarkened. There's no dark. It's white. Not P is true when P is false, because that's what this section means. So not P is true when P is false. Not P is true when P is false. Not P is true because it's undarkened when P is false, because that's what that means. When you're going over this, if you feel like it's kind of your mind is getting confused, and you forget, you say, believe me, do not worry about it, because it happened to me too. That's why I'm telling you exactly, you will not get confused if you do it the way I said it. If you don't do it the way I said it, then you will get confused, because you can look at these diagrams and like, what do they mean? I've had that experience. But if you do it systematically, it will no be problem. When you see a diagram and you see a letter at the bottom, the first thing you do is just you say the letter P, and then you put your finger on a section. If it's either going to be darkened or not darkened. If it's undarkened, then you say P is true. If it's darkened, then you say P is false. So P is true, and then you say when, and then you state what that section means. So P is true because it's undarkened when, don't forget the when P is true, because we're inside P. And that's exactly what line 1 says. P is true. This here, P, these two are the same. P is true when P is true. P is this is going to be a repetition of what I just did. P is true when P is true. P is true when P is true, because we're inside P. Down here, not P is false, because it's darkened, right? When P is true, because we're inside P. Not P is false when P is true. Okay, now I'm going to go into P and Q, but I don't want to keep going over this. I'll go over it again, but you could rerun the video. Just once you understand how to do it, it is easy, believe me. But if you don't do it systematically the way I said, you will get messed up. Okay, now I'm going to do two circles, P and Q. I'll diagram P and Q, and I'll show you how this works. Now we've got two statements, P and Q. Like today is Monday and it is raining outside, something like that. It doesn't matter what they mean, but whatever. So now I am going to diagram. If whatever I'm going to diagram, I write at the bottom, so you'll know what the diagram is of. So I'll say P and Q. Now, if P and Q is true, just using your basic understanding of the word "and" in English, you know what that means is that P is true and Q is true. Both have to be true. Now, the only section, we've got 4 sections, 1, 2, 3, 4. The only place in this diagram where we are inside the P circle and inside the Q circle at the same time is this section here, section 1. Okay, this is 1, 2, 3, 4. And these correspond to the truth table, which I'll talk about in the next lecture, but I'll take these off right now. But anyway, the point is this. The only time this P is true, P and Q is true only for this section. It's false for all the other sections. So since it's false for this section, I'll put a little darkened circle. So that's a diagram. That's how you diagram P and Q. Now, so if you're looking at this diagram, this is what you do. If you don't want to get messed up, because believe me, it's very easy to get messed up in this, and you will look at the diagrams and you have no idea what's going on. So that's why I'm telling you, just follow what I'm saying. The first thing you do is you put your finger on the statement being what, I can't think of the word, being diagrammed. So you put your finger here. So you say P is true. P and Q, that's the first thing, is, then you put your finger on a section. I'll do this one first. P and Q is true. I say true because it's undarkened. P and Q is true. Then you say when P is what? P in this section here, P is true. P and Q is true when P is true and Q is true, because we're inside. So what you say is, this diagram here says P and Q is true when P is true and Q is true. P and Q is true, because it's undarkened, when, and now we're inside the P and we're inside the Q, when P is true and Q is true. That's the only time it's true. Because in all the other sections, at least one of them is false. So to show that the other sections are false, you darken the section out. You put a darkened circle. So you could say, for example, I put my finger in this section. I could say P and Q, because that's what that says, is false when P is true and Q is false, because we're outside Q. I could say P and Q is false when P and Q is false when P is false and Q is false, because we're outside both circles. P and Q is false when P is false and Q is true. That's the diagram for P and Q. And the next lecture, I will go over this and give you other examples. I mean, again, it's a little counterintuitive at the beginning, but after you get used to it, it's very simple. You have to be systematic about it, though.